Hi folks, welcome back. So let's say you visit a website like llama.com, right? So you go to llama.com and everywhere you'll see description of models. You'll see Llama 3.1, Llama 3.2, 3.3, all good. But here everywhere you see something like this where it says 8B, 405B, then in Llama 3.2 it says 1B, 3B. Now the question arises, what does this B stand for, right? So if you read about it, it says 8B lightweight, but 405B flagship model, driving widest variety of use cases, right? Obviously you can see this is a small number and this is a big number. So what does this B stand for? What if I tell you that this B stands for billions of parameters, right? Billions. Now the question might come, but what are these parameters, right? To understand these parameters, I'll actually take you back to what we studied in the deep learning video. And I would actually recommend maybe you can play that video again because we discussed at length the deep learning and we did discuss the concepts of weights, biases. So if we consider this figure, here what we need to do is we need to see whether this figure is a circle, a square or a triangle, right? So it has to go through certain round trips, and we also studied about neural networks. So just a quick recap. A neural network is the brain of an LLM that learns how to understand and generate human-like text. And remember, neurons in the network are like tiny decision makers passing the information to each other, right? So these are neurons, right? These are neurons. They are actually kind of passing the information to each other. And in between, we also studied a concept of weights and biases, right? So weights, as I said, they are important scores that the model assigns to the connections between different parts of the network. And bias is like a starting point or adjustment that the model uses before it makes a final decision. Now you might ask, but why are we studying this? Yes, because this is the heart and soul of the parameter. So a parameter in a neural network are the internal variables, right? Internal variables that the model learns during training. Now, that's the good thing. The model is learning, right? Over the period of time, it is improving its accuracy. And these parameters are nothing but weights, biases that determine how the model processes and generates information. So now you can correlate why we studied weights, biases with the LLMs, because weights, biases are the heart and soul, what makes a parameter of an LLM, right? Now, another good thing about this is that the models with more parameters will also require more computational resources and memory. Obviously, yeah. If you see, if I have a more complex neural network than this, then it will have more weights, it will have more biases, obviously it will have more number of parameters. So that's where the difference lies. 1 billion parameters, 3 billion parameters, 405 billion parameters, which you see with Llama 3.1 models, right? So, and obviously they will require more computational resources as well. Now, the question is why these parameters are important. These parameters are important because they provide accuracy. So we say that properly tuned parameters enable the model to make precise predictions, improving overall performance. Pretty self-explanatory, right? If I have more parameters, obviously I can define, let's say if you're defining a certain thing, let's say you're going to look at a circle, you're going to look at an image recognition software. If you have more parameters, properly tuned parameters, obviously your decisions will be more accurate. It helps in learning complex patterns. Pretty simple. Like if you're talking about simple things, obviously you don't need that many number of parameters. But if you're talking about complex things, complex calculations, then obviously more the number of parameters, the better it would be for you, right? And also generalization. So well-adjusted parameters help the model generalize. Because remember, whenever we study LLMs, we always talk about the training data set. And there is some unseen data set, which is the testing data set, because we need to make sure what is the accuracy of our model. So well-tuned or well-adjusted parameters really help in generalizing. So even with unseen data, they perform really well. Now, even if you are still not understanding the parameters, I've taken a very, very simple example of T, right? So let's say there is a person A and there is a person B, right? You say that this person A makes a very good tea, right? And the person B doesn't make that great tea. Why that happens? So think in terms of LLM. What are the parameters when you're making a tea? The parameter could be, okay, I could go with a black tea, I could go with a herbal tea, I could go with a green tea, right? Then I could brew that tea at a certain water temperature. I could brew the tea, say, at 70 degrees. I could do it at 85 degrees. I could do it 100 degrees. And also the brewing time, right? So it could be 2 minutes, 3 minutes, 4 minutes. So what I'm trying to say is, just for making tea, there are 3 or 4 kind of parameters I can think of, or maybe more. How much sugar I add, okay? So that will make really tasty tea. Now here with parameters and with LLMs, we are talking about not 1, 2 or 3, but billions, billions and billions of parameters, right? So now I think you can correlate the importance of these parameters to LLM. And I've also taken a very good real world example. So the real world example I've taken is for the image detection software. Now image detection software, the parameters could be like with the T example. And the first parameter could be edge detection, so where it is looking for edges in the picture, right? So it needs to see how sensitive the model is to the edges. Then we could talk about the color saturation. So how much the model focuses on the colors in the image, like if you're talking about cats and dogs, it could be fur of the cat or the dog, right? Then we could also talk about the shape recognition. Again, taking example of cat and dog, what are the different features, like for the ear, nose, the body shape. So these are all different kind of parameters that you could use. Now, coming back to our original LLM. Now, when you study Llama, this is where you see all these models, 1B, 3B, 11B, 90B. I think now you can easily correlate. And one more thing, if you see this small model is 1 billion, and the multimodal, bigger models, multimodal means you can do text, you can do video, audio, right? So multimodal, it goes to 90 billion, and even the bigger ones like 3.1 had 405 billion. So I think now you can very easily correlate whenever somebody talks about billions parameters in models, LLMs, what these B or billions stand for. Thanks for watching.